Hi, let's quickly look at how to find the critical values. Okay, so for Z, question 1 says find the critical value Z sub 0 for a right tail test at a 0.05 significance. What it means is that to make understanding easy for you, let me sketch the curve so that you understand the logic behind whatever I'll be doing. So let me sketch a curve. Your curve shouldn't touch the x-axis. Okay, now when you shade this part, but they said it's a right tail. It's a right tail, meaning that this part is 0.05. 0.05. That's the meaning. Okay, 0.05. Now, if this part is 0.05, what will be this part? So when you subtract, when you take 1 minus 0.05, you get 0. What? You get 0.9500. When you do that, you get 0.95. When you add the 00 to it, okay, put it in 4 decimal places, 0.9500. So what to do with this 0.9500 is that you want to use it to find the z-score that will be here. That's the meaning of critical value of z. Okay, so you go to the z table. Now when you come to the z table, you look for 9500 among all these probabilities here. So let's look for 9500, 9500, 9500, 950. We have 9505 here and we have 9495 here, isn't it? 9500 is between them. So since it's between them, what you do is that you take the z-score of 9495. The z-score of 9495 is what? 1.64. And the z-score of 9505 is also 1.65. You add their z-scores together and divide it by 2. When you do that, you get 1.645. Okay, you get 1.645, which can also still be what? 1.65. So therefore your critical value of z for question 1 is 1.65 or 1.645. When you add 1.64 and 1.65 together and divide it by 2, you get 1.645. You can approximate it to 2 decimal place, 1.65, depending on the possible answers. If it's MCQs, if the possible answers give 2 decimal places, then you choose 1.65. If the possible answers give 3 decimal places, then you choose 1.645. Okay, yeah. So let's see the question 2. The question 2 says, find the critical value 0 for a left-tailed test at 0.01 significance. Significance is also known as the alpha. Okay, so let me sketch the curve for this one too. I've not drawn the line well, but pardon me for that. Okay, now this one says left tail, isn't it? Left, so meaning the left tailed. Okay, and it says what? 0.01, isn't it? So you put the 0.01 here, 0.01, isn't it? Now to get a critical value of z that should be here, you can also subtract this 0.01 from 1. 1 minus 0.01 will give you what? 0.9900, isn't it? 0.999900. So what this one to mean is that you should go to your z table and go and search for 0.9900. So we have 9900. Where do we have it? 9900, 992. Okay, you have 9901 here, 9998 here. 9900 is between the two of them. Okay, so to do this one too, you can take the z-score of this, which is 2.32, and the z-score of this too, which is also 2.32, 2.33. Add it together and divide it by 2, or you just take this, since this is more closer. Okay, 0.9901 is more closer to 0.9900 than 0.9898. So you can take the z-score of this one straightforward as your answer, or you take the z-score of the two of them and add it together and divide it by 2, or you just take this. So that's 2.33. Okay, yeah, 2.33. So therefore, your critical value of z will be what? 2.33. But look at something. This is at the left hand side, isn't it? So you have to attach negative to it. Negative 2.33. 2.33. Negative 2.33. Okay, that's your answer for 2. Now let's go to question 3. Question 3 says, find the critical values z sub 0 and negative z sub 0 for a two-tailed test given alpha equals 0.05. Alpha is the same as the level of significance. So to solve this one, please pay attention to this. This is a two-tailed test. How you go by it is quite different from how we did the other one. Okay. Let me change my... Okay. So, see. Two-tailed test, right? Two-tailed, meaning there are two tails. Two-tailed. Two-tailed, right? So we shade the two tails. Two-tailed. Now, you've been given a significance of 0.05. For a two-tailed test, you have to divide the significance by 2. The significance you've been given, you divide it by 2. When you divide it by 2, you get 0.025. So this place will be 0.025. 0.25. And this place too will be 0.025. 0.025. So this place will be 0.025. The other side will be 0.025. Okay. Then you subtract only one of the tails from 1. That is, if it is a two-tailed test, you divide it by 2 and subtract this from 1. When you subtract 0.025 from 1, you get what? 0.975. So you go to your z table and go and check 0.9750. 0.9750. So we have 9750 here. We get it directly. 0.9750. What does it correspond to? What's the z-score? 1.96. So therefore, the critical value of z for this is 1.96. So what it means is that this place should be positive 1.96 and this place should be negative 1.96. That's the meaning of your answer. That's the meaning of your answer. Okay. That is it. That is all. So let's go to question 4. Now for t, they say find a critical value t for a right tail test given alpha equals 0.10 and n equals 12. As for this one, you don't need to stress yourself much. What to do quickly is that since they say right tail test, just find degree of freedom. Degree of freedom is equal to, the formula for degree of freedom is n minus 1. Okay, n minus 1. That's the formula for degree of freedom. So for this one, its degree of freedom will be what? 12 minus 1, which is 11, isn't it? And they say right tail. Right tail means what? One tail, isn't it? 1. So the alpha is 0.1. So you just go to your t table straightforward. When you come to your t table, what was the degree of freedom? 11. That was 12 minus 1, isn't it? So you check where they've written one tail. Since they said right tail means one tail. and it was 0.05, isn't it, at 1 till 0.05. So you trace it to where 11 will be, you get 1.796. so this 1.796 is your critical value of t. The 1.796 is your answer for question 4. Okay, then for question 5, okay, sorry, you were given 0.1 rather. You were given 0.1 rather. So let's recheck. 0.1 at 1 till 0.1 against a degree of freedom of 11. So your answer should be 1.363. 1.363. Okay, 1.363. Then when you go to question 2, they've given you n to be 21. So what will be your degree of freedom if n is 21? What will be your degree of freedom if n is 21? Your degree of freedom will be 20. That is 21 minus 1, isn't it? 20. And it's a left tail test. Left tail test also means what? 1 tail, isn't it? So you also go and check it at where they've written 1 tail, 0.05. 0.05. So you also go and check it at where they've written 1 tail. So as you can see, 1 tail, 0.05. Then you trace it downwards towards a degree of freedom of 20. What do you see there? 1.725. So that is also your critical value of t, but you attach a negative to it because it says left tail, so you make it a negative answer. Okay, then for question 6, question 6 says find the critical values t sub 0 and negative t sub 0 for a two-tailed test given alpha equals 0.05 and n equals 26. For this one too, you find your degree of freedom. Your degree of freedom will be what? 26 minus 1, which is 25, isn't it? So if your degree of freedom is 25, you take this alpha. Now look at something here. Be very careful. The question says two-tailed test. So since it says two-tailed, when you go to your t table, check it very well. You realize that in your t table, they've written two-tailed here. They've written two-tailed here. Okay, so you check where they've written the two tail. Don't go and check where they've written the one tail. So check where they've written the two tail. What is the significance given to us over there? We're given 0.05, isn't it? And the degree of freedom is 25. Degree of freedom is equal to 26 minus 1, which is 25. Okay, so two-tailed. So two-tailed, 0.05 at two-tailed. And you take it down to degree of freedom of 25. It gives us 2.060. 2.060. So your answer for this one will be plus or minus 2.060 because it's two-tailed. There will be a negative side and there will be a positive side. So it will be plus or minus 2.060. Or you can say minus negative t equals negative 2.060 and positive t sub 0 is also equal to positive 2.060. So that is the end of this lesson. Okay, thank you for watching.